The German U-boat type, VII, Terror of the Atlantic. Opening, the undersea threat. September 3, 1939. Hours after Britain declared war on Germany, a German submarine, U-30, torpedoed the British passenger liner Athenia off the coast of Ireland, killing 117 people, including 28 Americans. This attack, which Germany initially denied, signaled the beginning of one of the longest and most brutal campaigns of World War II, the Battle of the Atlantic. For nearly 6 years, German submarines hunted Allied merchant shipping across the Atlantic Ocean, attempting to strangle Britain's supply lines and force her out of the war. The primary weapon in this campaign was the Type VII U-boat, the most produced submarine class in history and arguably the most effective submarine of World War II. The Type VII U-boat was not a revolutionary design. It was an evolution of submarines Germany had developed during and after World War I, but it was refined, practical, and deadly. Germany would build over 700 Type VII submarines during the war. They would sink thousands of Allied ships, totaling millions of tons of shipping. They would come terrifyingly close to winning the Battle of the Atlantic and, by extension, World War II itself. Winston Churchill later wrote, "The only thing that ever really frightened me during the war was the U-boat peril." Origins and development. Germany's submarine force had a distinguished, if controversial, history from World War I. German U-boats had waged unrestricted submarine warfare against Allied shipping, achieving remarkable success, but also contributing to American entry into the war after U-boats sank American ships. By the end of World War I, Germany had built over 300 submarines and had developed considerable expertise in submarine design and operations. The Treaty of Versailles, signed in 1919, prohibited Germany from possessing submarines. This restriction, like many aspects of the Versailles Treaty, Germany eventually circumvented. In the 1920s and early 1930s, German naval engineers continued submarine development work clandestinely, using Dutch, Finnish, and Spanish companies as fronts. They designed submarines officially for foreign navies, but with the clear intention of eventually building similar boats for Germany. When Adolf Hitler openly repudiated the Versailles Treaty's military restrictions in the mid-1930s, Germany immediately began rebuilding its submarine force, the U-boat service, or Unterseebootwaffe. The first new submarine, U-1, a Type II coastal boat, was launched in 1935. However, the German Navy, the Kriegsmarine, needed a larger, more capable ocean-going submarine. The Type VII was the answer. The Type VII was based on earlier designs, particularly the Finnish submarine VII, which German engineers had designed in the late 1920s. The chief designer was Hans Techel, working for the design office IVS, or Ingenieurskantoor voor Scheepsbouw, in the Netherlands. This office was actually a front for German submarine development work. Techel's design emphasized balance between size, range, armament, and cost. The goal was a submarine that could operate effectively in the Atlantic, but could also be mass-produced quickly and cheaply. The first Type VII, designated Type VII-A, entered service in 1936. Only 10 Type VII-As were built before the design was refined into the Type VII-B, which featured increased range and improved handling. 24 Type VII-Bs were completed before the outbreak of war. These early boats validated the design concept and provided training for crews and testing of tactics. When war began in September 1939, Germany possessed 57 submarines total, far fewer than the 300 Admiral Karl Donitz, commander of the U-boat force, believed necessary to defeat Britain. The immediate priority became mass production. The Type CC, introduced in 1940, became the standard production model. With minor modifications for easier mass production and slightly increased fuel capacity, the Type CC would become the backbone of the U-boat force and the most produced submarine variant in history. Design and technical specifications. The Type 7C was approximately 220 feet long and 20 feet wide. It displaced 769 tons on the surface and 871 tons submerged. These dimensions reflected a compromise. The boat had to be large enough to carry adequate fuel, weapons, and supplies for extended patrols, yet small enough to be maneuverable and difficult for enemies to detect. The submarine had two propulsion systems. On the surface, it used two diesel engines, each producing 1,400 horsepower, giving a top speed of about 17 knots. Submerged, it switched to electric motors powered by batteries, producing 750 horsepower combined, with a top submerged speed of about 7.5 knots. This dual propulsion system was standard for submarines of the era and reflected the fundamental nature of World War II submarines. They were essentially surface ships that could submerge temporarily, rather than true underwater vessels. The boat's operating depth was officially rated at approximately 230 feet, with a crush depth, the depth at which the hull would collapse from water pressure, of around 800 feet. In practice, skilled commanders sometimes exceeded the official depth limits when evading depth charge attacks, pushing their boats to 300 or even 400 feet, well beyond the design specifications, but sometimes the only way to escape destruction. The Type VII carried 5 torpedo tubes, 4 in the bow and 1 in the stern. The standard loadout was 14 torpedoes. The primary torpedo was the G7A, a steam-powered torpedo with a range of about 6,000 yards at 44 knots, or longer range at reduced speed. Later in the war, Germany introduced the G7E electric torpedo, which left no wake and was harder for targets to detect, though it was slower and had less range than the steam torpedo. The deck gun, initially an 88mm cannon, provided surface armament for attacking unarmed merchant ships without expending valuable torpedoes. Later models increased this to a 105mm gun. Anti-aircraft armament initially consisted of a single 20mm cannon, but was progressively increased as Allied air power became more dangerous. By late war, Type 7Cs bristled with multiple 20mm and 37mm anti-aircraft guns, reflecting the desperate need to defend against aircraft. The crew consisted of 44 to 52 men, depending on the specific variant and patrol requirements. Officers included the commander, executive officer, engineer officer, and watch officers. The enlisted crew included engineering ratings, torpedo men, radio operators, sonar operators, and deckhands. Living conditions were notoriously cramped. Men slept in narrow bunks stacked 3 high, or in spare spaces wherever they could find room. The boat's interior was crammed with equipment, supplies, and spare torpedoes, leaving minimal space for crew comfort. There was no refrigeration, so fresh food lasted only a few days into a patrol. After that, the crew subsisted on canned and preserved foods. Water for washing was severely limited. The air inside the boat grew increasingly foul as a patrol progressed, especially when submerged for extended periods. Humidity was constant, causing mold to grow on everything. The smell, a mixture of diesel fuel, unwashed bodies, spoiled food, and the chemical composition of the air itself, was notoriously terrible. Tactics and operations. The Type 7's operational profile typically involved a patrol lasting several weeks. The boat would depart from its base in occupied France, Norway, or Germany and transit to its assigned patrol area, often in the central or western Atlantic. The transit could take a week or more, during which the boat traveled on the surface as much as possible to conserve battery power and make better speed. Once in the patrol area, the boat would hunt for Allied convoys. This involved maintaining watch from the conning tower while surfaced, using lookouts and later radar to detect ships. When a convoy was spotted, the U-boat would track it, radioing position reports to headquarters so other nearby U-boats could converge. This wolf pack tactic, developed by Admiral Donitz, was devastatingly effective. Multiple submarines attacking a convoy simultaneously could overwhelm the escorts and sink numerous merchant ships. Attacks typically occurred at night on the surface. The U-boat's low profile made it extremely difficult to spot in darkness. The submarine would maneuver to an attack position, often inside the convoy's defensive perimeter, fire torpedoes at the largest or most valuable targets, and then attempt to escape before the escorts could respond. After firing, the U-boat might dive or might continue attacking on the surface, depending on the situation and the commander's aggressiveness. Submerged attacks, while safer, were more difficult. The submarine's slow underwater speed made it hard to get into attack position. The periscope was the only means of observing targets, and raising it risked detection. Submerged, the boat had limited battery power and had to surface eventually. Most successful U-boat commanders preferred surface attacks when possible, reserving submerged attacks for daylight or when escorts were too alert for surface approach. When depth-charged by escorts, the U-boat would dive as deep as possible and attempt to evade. The crew would rig for silent running, shutting down all unnecessary equipment and moving as quietly as possible. Even small sounds, a dropped wrench or a slammed hatch, might be picked up by Allied sonar and give away the boat's position. Depth-charge attacks were terrifying experiences. The crew could hear the charges splashing into the water above them. Then came the explosions, massive concussive shocks that shook the boat violently. Lights would fail, equipment would break loose, hull plates might crack, allowing water to spray in under tremendous pressure. Men would be thrown around the interior. Some would panic, and it required iron discipline to maintain order. The happy time and growing peril. The period from mid-1940 to early 1941 was called the happy time by U-boat crews. France had fallen, giving Germany bases on the Atlantic coast that dramatically reduced transit time to hunting grounds. Britain stood alone, and her convoy escort forces were stretched desperately thin. Allied anti-submarine warfare tactics were primitive. U-boats sank ships at a phenomenal rate with relatively light losses. Individual commanders achieved fame, or infamy depending on perspective, for their success. Otto Kretschmer in U-99 became the top-scoring U-boat ace, sinking 47 ships. Gunther Prien in U-47 had earlier penetrated the British naval base at Scapa Flow and sank the battleship Royal Oak, a stunning blow to British prestige. Joachim Schepke in U-100 and Wolfgang Luth in multiple boats also achieved high scores. These aces were celebrated in Germany as heroes, their exploits prominently featured in propaganda. However, the tide gradually turned. Britain devoted enormous resources to anti-submarine warfare. Convoy escort numbers increased. New weapons, particularly ahead-throwing depth-charge projectors like Hedgehog, proved more effective than traditional depth charges. Most critically, improved radar allowed escorts to detect surfaced U-boats at night, negating the submarine's primary advantage. The introduction of escort carriers, small aircraft carriers accompanying convoys, extended air cover far into the Atlantic. Previously, there had been a mid-Atlantic gap beyond the range of land-based aircraft where U-boats could operate with relative impunity. Escort carriers closed this gap. Aircraft could spot submarines from far away and attack with depth charges or rockets before the submarine could dive to safety. By 1943, the Battle of the Atlantic reached its crisis point. In May 1943, U-boat losses spiked dramatically. Donitz temporarily withdrew his boats from the North Atlantic, conceding defeat in what had been the primary hunting ground. New technology, particularly acoustic homing torpedoes that could target escort ships, briefly restored some U-boat effectiveness. However, the Allies countered with their own innovations, and the overall trend remained against the U-boats. The climax and defeat. From mid-1943 onward, serving in U-boats became increasingly suicidal. Allied anti-submarine forces had achieved superiority. Advanced radar could detect even periscopes or snorkels. Improved sonar made submerged submarines easier to track. Escort tactics had been refined through hard experience. Most importantly, Allied code-breaking, the ultra-secret, allowed the Allies to route convoys away from known U-boat positions and direct escort forces to intercept submarines.
German submariners, knowing the odds were against them, nevertheless continued to patrol. They were volunteers, generally elite troops, motivated by patriotism, camaraderie, and a sense of duty. They knew their chances of survival were poor. The U-boat service suffered a 75% casualty rate during the war, the highest of any German military branch. Of approximately 40,000 men who served in U-boats, about 30,000 died. The Type VII continued to be produced until the last months of the war, though later production focused on more advanced types like the Type 21, a revolutionary design that was a true submarine rather than a submersible surface ship. However, the Type 21 came too late and in too few numbers to affect the war's outcome. The Type 7 fought to the bitter end. Technical evolution. Throughout the war, the Type 7 was continuously modified in response to operational experience and changing threat environments. The most significant modification was the schnorkel or snorkel, introduced in 1944. This device allowed the submarine to run its diesel engines while remaining submerged at periscope depth, drawing air and expelling exhaust through a tube that extended above the surface. This allowed the U-boats to charge batteries and transit without surfacing, greatly improving survivability against radar-equipped aircraft and ships. However, the schnorkel was not a perfect solution. The boat could only travel slowly while snorkeling. The device could be detected by radar. The diesel engines, running in the sealed boat, would create pressure changes that were extremely uncomfortable for the crew and could even cause injuries. Nevertheless, the schnorkel significantly extended U-boats' operational capability in the final year of the war. Other late-war modifications included improved anti-aircraft armament, radar warning receivers to detect when the boat was being tracked by enemy radar, and various coatings and treatments intended to reduce radar reflection or sonar detection. These measures had limited effectiveness, but demonstrated the continuous effort to maintain the Type 7's combat viability against increasingly overwhelming opposition. The human element. The story of the Type 7 cannot be told without acknowledging the human dimension. These submarines were operated by men, often very young men, who endured conditions that are difficult to comprehend. A typical war patrol lasted 6 to 8 weeks. During this time, the crew lived in a metal tube, constantly damp, cold, or unbearably hot depending on location, with no privacy, inadequate food, and the ever-present knowledge that death could come at any moment from a depth charge, torpedo, aircraft attack, or simple mechanical failure.
The psychological strain was immense. Men had to function normally despite the stress, maintaining the complex machinery, standing watch, carrying out orders. When under attack, they had to remain calm while explosions shook the boat and water sprayed through sprung seams. Some men broke under the pressure. Others adapted and even thrived in the environment. The bond between crew members was extraordinarily strong. They depended utterly on each other for survival. U-boat commanders were typically young, often in their 20s, yet they bore enormous responsibility. They had to navigate, find targets, conduct attacks, evade counterattacks, maintain crew morale, and ultimately decide whether to continue attacking despite danger or to withdraw. The best commanders combined technical skill, tactical ability, courage, and leadership. They earned intense loyalty from their crews. The ethical dimension of U-boat warfare was complex. U-boat crews were fighting for a regime that was committing unprecedented atrocities. Yet most submariners did not see themselves as participants in Nazi crimes. They were naval officers and sailors doing their duty. They attacked enemy shipping, a legitimate military target. Most U-boat commanders respected maritime traditions and rescued survivors when possible, though this became increasingly rare as the war progressed and such actions became too dangerous. There were exceptions. Some U-boat commanders committed war crimes, machine gunning survivors or ramming lifeboats. These actions, while not typical, occurred and cannot be excused. Conversely, there were acts of remarkable humanity. The most famous involved Werner Hartenstein, commander of U-156, who torpedoed the British troopship Laconia in 1942. Upon discovering the ship carried Italian prisoners of war, Hartenstein surfaced and began rescue operations, radioing for help and taking hundreds of survivors aboard his submarine and towing lifeboats. When an American aircraft attacked despite clear Red Cross markings and rescue signals, Hartenstein was forced to dive, abandoning many survivors. The incident exemplified the moral complexities of submarine warfare. Legacy and historical significance. The Type 7 U-boat represents both remarkable engineering achievement and a cautionary tale about the human cost of technological warfare. From an engineering perspective, the Type 7 was an excellent design. It was effective, reliable, and producible in quantity. It could be built in less than a year, and Germany's dispersed production system meant that even heavy Allied bombing couldn't stop U-boat production entirely. Over 700 Type 7 boats were built, making it the most produced submarine class in history. These boats sank approximately 2,800 Allied ships, totaling around 14 million tons. They came extraordinarily close to severing Britain's Atlantic lifeline. Had the U-boats succeeded, Britain would have been forced out of the war, and the entire course of history would have been different. However, the U-boat campaign ultimately failed. Allied countermeasures, superior industrial capacity, technological innovations, and code-breaking combined to defeat the U-boat threat. The human cost was staggering on both sides. 30,000 German submariners died. Allied merchant seamen suffered even higher casualties, with approximately 36,000 killed serving in merchant ships. Thousands more Allied naval personnel died fighting U-boats. After the war, many Type 7 boats were scuttled or destroyed. Some were divided among the victorious powers and studied extensively. Captured Type 7 boats and detailed technical documentation heavily influenced post-war submarine development in multiple countries. Soviet submarine design, in particular, showed clear influence from captured German submarines and engineers. Modern perspective. From today's vantage point, the Type 7 represents a particular moment in submarine development. It was arguably the best conventional submarine of World War II, the peak of the submersible surface ship concept. Nuclear power and modern technology have created submarines that are true underwater vessels, capable of remaining submerged indefinitely, traveling at high speeds underwater, and operating at depths the Type 7 could never reach. Yet certain aspects of the Type 7's design remain relevant. The basic torpedo attack problem, detecting targets, maneuvering into attack position, firing weapons, and evading counterattack, remains fundamentally similar. The importance of crew training, maintenance, and morale remains unchanged. The devastating effectiveness of submarines against surface shipping, demonstrated so effectively by the Type 7, shapes naval doctrine to this day. The Type 7 also stands as a memorial to the men who served and died in these boats. The crews were volunteers who chose to serve in what became the most dangerous duty in the German military. They fought with skill and often with courage, even when the cause they served was unjust. Their sacrifice, and the sacrifice of their enemies who died fighting them, should not be forgotten. Conclusion. The Type 7 U-boat was one of World War II's most significant weapons. Not the most powerful, not the most sophisticated, but perhaps the most effective at its specific mission. For years, these submarines hunted across the Atlantic, sinking ships, threatening Britain's survival, and tying up enormous Allied resources in the effort to combat them. The Battle of the Atlantic was ultimately a battle of production, technology, tactics, and human endurance. The Type 7 was an excellent platform for the U-boat force, but it was not enough. Allied industrial might, technological innovation, and determination prevailed. Yet it was a close-run thing. Had circumstances been slightly different, had the Type 7's advantages lasted longer, had Germany produced more boats earlier, the outcome might have been different.
The Type 7 U-boat stands as a testament to engineering skill, to tactical innovation, and to the young men who took these machines to sea knowing they might never return. It represents both the terrible effectiveness of modern weapons and the ultimate futility of trying to win wars through attrition alone. The U-boats could sink ships, but they couldn't sink Britain's will to resist or America's industrial capacity. Today, Type 7 U-boats rest on the ocean floor across the Atlantic, entombed with their crews, silent monuments to one of history's longest and most brutal naval campaigns. They're reminders of the cost of war and the courage of those who fight, regardless of which side they serve. The Type 7 was a remarkable machine, but in the end, it was the men who mattered, on both sides, and their sacrifices should be remembered.